Yeah, here we are. Hello, good evening. This is actually, I just realized, like the second event we do in this November of 2022. Yeah, and I'm happy to have Leo today with us here from AOE in Wiesbaden. And yeah, let me maybe say a few words about Leo first, and then we can go straight to his interesting talk. So Leo has quite some expertise in user-centric software development in an industrial context and years of experience in front-end development. And he's a full-stack developer at AOE and currently applying like the full stack know-how and front-end expertise to his projects in the area of Industry 4.0. And he was also previously involved in hybrid app development and front-end development for various projects and companies. And today he will tell us about advantages and challenges of running web apps on limited hardware, right? So yeah, anything from your side, Leo? We are ready to start.
Not much to add. I'm ready.
Okay, cool. So before we start, just a short note. As always, please put any comments and questions in the YouTube chat and we will pick them up after the talk. And yeah, hopefully, as this initially was planned, like as an on-site meetup, it was not possible this time for some reasons. We will do this next year, and then also we finally can do the things like some raffle with some nice magazine, like the Off-Screen magazine, tackling the human side of technology, or also like books like a cool TypeScript book from Stefan Baumgartner and a bit of other swag, like crazy stickers and what. Yeah, let's see next year. And with that, enjoy and stage is yours.
Yes, thank you, Jan. And yeah, happy to be here. And let's get started. So as Jan already mentioned, my name is Leo Buck. I'm a developer at AOE. And in the last 1.5 years, now I've been working on a project in a kind of different context, which is running on an embedded system, actually. And I want to share some insights about that with you today. I guess all of you have already developed single-page applications, or at least many of you, and have worked with one or more of the popular front-end frameworks that are out there. Maybe some of you have also worked on a hybrid app or an Electron app and used web apps outside of their classical browser web context. And yeah, today I want to show you another context where we can see web apps play out their enormous potential, which is an embedded system. And yeah, that's what I'll be talking about. What I will not be talking about, unfortunately, is the project itself, since it's not finished and not publicly available yet. But I will share lots of technical insights with you and the challenges we faced and what we learned. All right, first of all, let me give you some rough idea of the project context. Let's imagine a restaurant. And you all know these handheld devices the waiters are walking around with to do payments. So kind of like a payment processing device, which sometimes looks like this, which has a small screen that can be used to configure payments and to be interacted with using a touchscreen. And let's imagine this one is also accessible by a mobile app and can be configured that way. So like from another context and from another touch point here. And also this restaurant has some kind of desktop PC behind the bar, which can also access the device and has a user interface where we can do some configurations. And yeah, basically all of these 3 platforms here expect the same feature set. But of course, we want to have some improvements for larger screens. For example, if you want to see, I don't know, some complex configuration page on the desktop one, it should be optimized for a large screen so the user, can interact with it in a better way. And if you look at these three layouts and set a feature parity between all of these three, there might already be some voice inside of you screaming mobile first responsive design. Since we have a small screen over here, we have a slightly larger screen here, and a big screen, and we don't know the platforms of each of these devices, but we know they all want to have the same features. And so we thought as well this might be a mobile first responsive web app actually, and so that's what we did. We actually decided to try to serve a web app on that device. That kind of looks like this. We have a Go backend here running on the device, which is serving a web app, a single page application, which can then be accessed by the 2 or more clients out there on the local network the device is connected to. And to make, so these are of course the less critical parts, since these are like regular devices to be used with web apps. But we have a critical part on the right side, which is of course the handheld device over here, which is running on very limited hardware. And fortunately we can run an Electron app on that one. And this is then used to display the web app on screen. And that's how the user can interact with that device using a touch screen. And talking about hardware limitations, the hardware we're running on here is a 4 cores 850 megahertz CPU. So luckily we get 4 cores. Initially it was just 2 cores planned, but now it's 4. But it's 850 megahertz, so it's really not that much, and it's on an ARM architecture and 1 gigabyte of RAM. And there's also our backend running, which needs to do a lot of heavy mathematical calculations. In our example, maybe some really difficult calculations to get the final payment result for our customers. Of course, in the real app, it's something different. But this backend is doing lots of heavy lifting here, and it's further limiting our capacity that's available, or our hardware resources that are available to the front end. And so you might think, why would it even make sense to try and let a app like that run on such a limited hardware, since we're in such a limited context here? And of course, there's an obvious reason to not do that, what we did, which is set performance. And normally, and most of our competitors in that area would have tried to display the user interface using something natively compiled. So you might want to use the limited resources you have as good as possible, of course. But we thought the standard for an application or for a user interface shouldn't be the best possible performance, but the best possible user experience. And we thought if you can provide that on a specific hardware with a web app, it's worth considering. And so we kind of did some POC, which showed that it's actually possible for us to deliver a good user experience with a web app. And since we knew that, there's a lot of positive side effects resulting from this approach. First of all, to the users, of course, and this one is coming kind of from this architecture we've seen here. We're running on a network here, and we have lots of clients in that network that try to access our device. And this feature comes for free with web technologies, since being accessible on a network is what web technologies are created for. And secondly, we can also benefit from lots of experience and powerful tools and technologies to create responsive user interfaces, of course, since we've been doing that on the web for quite some time. And that's something you might not be able to achieve that easily from some native UI framework. And of course, which is always a benefit you get from using web technologies, a native app will not work on any kinds of devices, and you might need to develop your app for each of the platforms you try to access or you try to make it available, and that's quite wasteful. And yeah, so we also get that kind of for free, since web technologies are platform independent, of course. And so we can also, yeah, we have a lot faster development time because we don't need to develop two things and manage two code bases and all of that. So yeah, that's another benefit. And speaking of development, when it comes to the development process itself, there's a lot more we can benefit from, since obviously our web application is running in a browser. And that means during development, we can develop our UI on a browser actually. We can show our user interface around on a browser while it's being developed. So we can really achieve small delivery times. We can do small updates. We can just, work iteratively better without the need to always run our user interface or see our user interface on the actual final hardware. Also, we can send around the Electron app we are running on the device. We can even test our UI in a browser. So we can use tools like Cypress to do end-to-end testing. And we can do very detailed performance analysis since the Chrome DevTools have that awesome feature, this performance analyzer, which I will be talking about a bit more later on. And yeah, so basically we can benefit from all the awesome tools which are provided by the JavaScript ecosystem. Of course, all of these are not unusual for us as front-end developers, but they're pure luxury in the world of embedded development, and they're really giving us an advantage in terms of development speed and also test coverage, since yeah, we can run our tests everywhere and we don't need a device to test stuff. Okay, then let's dive a bit into what we actually did or needed to do to provide such said good user experience to the user. So first thing we did a lot was some kind of lazy rendering mechanism, which is used to like recycle existing repeating elements on the site during scrolling or swiping through lists. So basically, if you look at this list, this one would just be showing these three items you can see here. And while the user is scrolling, these will be just moved around and to like create the illusion of continuous scrolling. But instead, our lazy rendering library here is just flipping around some HTML elements. And yeah, that can, of course, for large lists and for complex data collections, drastically reduce the amount of items we need to render, since we just need to render the visible items here. And so the browser needs to process a lot less HTML, and that makes the initial paint of such pages containing these complex lists a lot faster, especially a lot faster if you're running on a limited hardware, where rendering always takes more time than usual. And yeah, same goes for something like this vertical scrolling here. Horizontal scrolling here, sorry, which yeah, can be done by the same mechanism. So just once we are swiping on a slide, the next slide will be displayed. And yeah, that helped a lot. Yeah, so next thing, of course, which is careful and intentional change detection. Since our app is running on Angular, we were going for the on-push change detection strategy. to make sure that we have the full control over when and why a component re-renders, and to reduce the amount of re-renders as much as possible. And yeah, so that way we could get full control over when and why a component is rendering, since I've already mentioned, of course, re-rendering and change detection is like the most critical part of a web app when running on limited hardware. And yeah, the on-push strategy gave us as much control over that as we could get. And yeah, next thing, I've already teasered that one, is performance analysis. Mostly using the performance analyzer in the Chrome browser. That one is really awesome to analyze critical parts of the app and to find out which JavaScript functions take long to execute. So you can see these fire charts here displayed by the performance analyzer, which are like graphs of the runtime of specific functions. And you can also see which function calls which, and how long these functions take to execute. So we can find out if a long-running function might block our user interface here. One of these examples you might see here, this one is something that's fired inside of an animation frame. And it's taking quite a bit of time. I think it's more than 5 seconds here. And you might see above here the frames in the frames of the app. And you see during that time this thing here fired, there's nothing visible on the page. And that's something we need to take care of course, because that's really blocking the user from interacting with our application. And that's another huge benefit from using web technologies here, because we can just run this performance analysis inside of the Electron process, which is actually running on the device itself, so on the final hardware, and then access and analyze it on the Chrome remote dev tools on the development machine itself. So we can really get some detailed insights here. And then we can use that to maybe speed up some of the long-running functions, or at least if we can't speed them up, try to move them to some other point in time where it doesn't block the user that much. So the user gets a snappy user interface. All right, one thing that I always also do a lot while developing the front-end part of that app is letting the performance monitor run in the background. So on the right side of my DevTools, which are already open most of the time. And so you can always quickly identify memory leaks and critical peaks during development, which is of course a really good way to identify leaks and problems with the app as soon as they appear and as soon as you build them in. So that has also helped a lot, identifying some things before even deployed to the device itself. And last but not least, since some long-running operations cannot be optimized further after some point, we try to provide the user some feedback on process, and that something actually happened after his interaction, to at least show the user, okay, we got it. You interacted with the UI, but it's just taking some time, and that's a great way to improve felt performance without the need to actually improve the performance itself. Of course, that's to be used with care, since you can easily overload your application and your user interface with silly animations, and then it won't have the same effect as it has when you use it just on a few particular places. All right, so that's basically the largest categories and the most important things we did to improve performance. And in conclusion, none of these mentioned things are special for this kind of UI development, basically. I guess most of you have used some of those yourself, and I think that's pretty awesome because it shows how versatile and powerful web apps are becoming, and in what special contexts they can be used in, and on what limited hardware they can be used in without too much special knowledge, except for some performance tweaking. And yeah, so it means anyone can develop such a user interface, basically. You just need to get some knowledge in performance tweaking here. And yeah, I think that's awesome. So finally, what I did, since I'm a bit sad, I can't show you a final result of how the final user interface is really looking and working on said hardware. I prepared something else for you, which is a comparison between popular front-end frameworks, and I tried to see which frameworks perform best on an embedded device like this. So basically, I wanted to have some fun with numbers in the end here, and I tried to get some comparable bases, of course, for each of these frameworks. And for that, I used the Real World app. I don't know if you know that one. It's an example app implemented in many different frameworks. So it's the same app, but different implementations. And I calculated the Lighthouse performance score for it. And I did it once on my Mac. And I did it once on a Raspberry Pi 3, which acts as my kind of embedded system here, which has a very similar hardware compared to the one we're actually using. It has a 4-cores, 1.2 gigahertz ARM CPU and 1 gigabyte of RAM. So it's pretty close. It's a bit stronger than the actual system, but pretty close still. And yeah, so what you can see here are the results. So on these greenish bars, you can see the score from my MacBook. And on those pinkish bars is the score calculated on the Raspberry Pi. And yeah, what you can see here, I selected Solid, Svelte, and Preact as the like more performance-oriented frameworks, and React and Angular as like regular popular front-end frameworks here. And yeah, as you can see, obviously all of these frameworks perform worse on the Pi than on my MacBook here, which was to be expected, of course. But it looks like all of them seem to stay at a pretty usable level of performance. Well, maybe except for the React app. I don't know what happened there. That one really doesn't look that good. But yeah, of course, what we're seeing here is not representative for all the frameworks, since we're looking at implementations here. And a lot of the performance problems we might get are highly depending on implementation details. And yeah, so that might not be representative for all the frameworks, of course. So we shouldn't really compare the absolute numbers of these scores here. And yeah, but we can see some tendencies. And what we also can see here, and which is, in my opinion, the most interesting metric we can get from here, is like the performance drawback framework gets when being used on limited hardware. So that would be like the difference between those two bars here is like, you know, the loss of performance you get by being used on limited hardware. And yeah, as you can see, Preact seems to perform pretty good in that one. Don't know if you know Preact. Preact is just a like a smart and really efficient diffing library for the virtual DOM of React. And yeah, so that one seems to perform pretty good here. And it seems to have the least loss of performance when being used on limited hardware. Yeah, and as I already mentioned, of course, handle these numbers with care, since they might not be representative for the frameworks, since performance, yeah, always highly depending on individual decisions. And even though the app structure for all of these frameworks or all of the apps I tested here are the same, and they should, or they are meant to be representative for the frameworks themselves. But of course, there's also a tendency for people implementing things in more performance-oriented frameworks to also take more care of performance. So this might be a bit biased here, which also could be a reason why Angular and React are performing that much worse on the limited hardware than on the powerful hardware. All right, and that marks the end of my talk. I hope you enjoyed, and yeah, maybe now would be the time to answer some questions if we have any. I'm not sure.
First of all, thanks for the talk. Thanks a lot.
It was a pleasure.
It's very interesting. I don't see any question in the chat, but I myself have a few questions maybe, or we can maybe talk a few minutes about stuff which came to my mind. Like you said, the app, the framework you used is Angular, right? And you decided for the on push change detection strategy, and was the decision for Angular already made when it was decided to go to run on a Raspberry or on the hardware, or was it more like, okay, you saw like Angular as the most fitting framework to run there? What can you elaborate maybe a bit? What was the setting before? Just curious.
Basically, the main driver for the decision to Angular was the existing expertise. Which made the decision against other more performance-oriented frameworks actually was, since we did our POC and also already saw that Angular was fitting good in our case, we decided to go for it, as I mentioned, on the one hand, because of existing expertise, and so to reduce the risk to make the wrong decisions in early stages of the project due to lack of experience. Secondly, which was the reason why we went for one of the popular frameworks instead of the more performance-oriented ones, was because we were a bit afraid that maybe the community of those is not as large as the ones for the popular frameworks. And we thought, why risk not getting some important tool or library we might need just because of deciding for a more performant framework that we don't even need in the end, because Angular is like performant enough in our case. So yeah, basically that was what led us to that decision.
Yeah, totally can relate it. That's always a challenge to in the decision making to balance between, okay, this one framework is really performance oriented, but the ecosystem is maybe too small when you run into like specific issues. You maybe do not find much answers on Stack Overflow, or
Exactly.
It's too much in a beta state still. Also, they are like having performance on their roadmap, or like even the numbers are already better than established frameworks, but maybe it's not so major yet, right? So this is sure.
Exactly. And to be honest, I also did this performance comparison here when we were like 1 year into the project. So I couldn't see how the performance scores actually were before making that decision. Maybe Preact would have been another option here, but I guess we would probably have went to Angular anyways.
But I would assume there is no reason, at least not around performance, to now change like the framework. Yeah. What were like the most or the trickiest challenges around performance? For me, it sounds like you solved much of this potential performance issues within the framework with this detection strategy in Angular, but were there other issues and challenges you really need to tackle? Like I could imagine in comparison to like Svelte, for example, as a compiler, like shipping the whole bundle to the browser in general might be
Yeah,
a
so
topic, or was it more around like the asset, so to say, or like the amount of maybe data which is gonna be rendered and like the DOM size, so to say. You mentioned like the challenges you had and the solutions you did with scrolling vertically, horizontally, and things like this.
yeah, basically most of the problems we could solve were based on the amount of HTML processed by the browser. So that's what I already mentioned. And I think I didn't find anything where I would say, okay, maybe another framework would have been a better choice here. So maybe there isn't any like fundamental difference between those frameworks, or at least in terms of performance awareness, or we already chose one that made it more easy to take care of performance. One thing that came into my mind when you asked that question was this a thing we saw, like we had some timer in one part of the app, which was always counting up every 100 milliseconds and then updating some small timer in one side of the view. And that one was actually pretty laggy, since in the backend, there was lots of calculations happening during that time. This timer is being displayed, and therefore, don't know if you know that, but this set interval function of JavaScript is not guaranteed to deliver or to call the callback you give to it in the exact time that you specify. And it can be delayed, and it can also be skipped if the browser is on, or the system the browser is running on is under heavy load. And that's actually what we saw there, since the system was already under heavy load, and therefore the browser decided to delay some of these callbacks and skip them, and so this timer was getting pretty laggy on the final hardware, which was something we didn't see on any of the development machines, of course, since the calculations happening there didn't put our systems under stress. And yeah, that was also something pretty specific, which we needed to solve.
No, okay. Yeah, I would say like the browser on the embedded device is not like the first citizen for the operating system, or
Definitely
like,
not.
yeah, it's always the balance, what the CPU allows coming from JavaScript side, mostly from the browser, and how this fits into like frames. Yeah.
Yeah, and also you don't have any control over that, so you just need to accept that because you can't force
request an
the
animation
browser
frame.
to.
Yeah.
Yeah, exactly. That's it. It's just a request, and the browser decides, or the system in the end decides if it likes to do it. So you're really not not in a position of control as a front-end developer on such a system. Exactly.
Yeah. Okay. In the beginning, you also mentioned that you bundled the PWA in an Electron app, right?
Yes.
Like that's what's running on the device, right?
Exactly. Yeah.
did you encounter any also again performance issues or challenges like getting the stuff into an Electron app and make this available on the device?
Actually not.
Or was it straightforward?
Creating Electron apps for Linux on ARM32 CPU is actually just setting the right environment variable when running build. So that was actually pretty easy. And I don't think Electron is causing that much performance issues here. I'm not sure actually, since we don't try to run it without Electron, but yeah, since it's just a pretty thin layer around the app itself for us, I think it's fine. So we could even, if we see some performance issues coming in, we could even remove the Electron app from it because it's really a thin layer around it. We basically use it to do things which would require a bit more work on the system, like switching dark and light mode, which is a lot easier when we just do that in the Electron shell and not trying to set it as a system setting, stuff like that. So it's just some convenience basically for us. And it's also a lot easier as a side effect to do reviews and to like get our app tested by someone who isn't a developer, since we can just pack this Electron app, and since it's platform independent, we can also just pack it for like a Mac and then just send it around as a file, and someone can open it and do some testing.
Okay. Did you also use some progressive web app features like offline functionality or connecting to like native functionalities, Bluetooth, other stuff, or is it like nothing special there from the requirement side, so to say?
Nothing special there, especially not on this hardware connection side, since we wanted the app to run on as many, so as an external client to run on as many platforms as possible, and the hardware integration just lives in the handheld device. And yeah, since we also already needed to integrate the something like access to Bluetooth or something ourselves there, it was pretty easy to just provide it as an API to our client, which also has a nice side effect that, of course, also those things are configurable from the remote devices. And yes, offline functionality also not that relevant for us, since we're already running on a local network and only on a local network, and so we didn't need to care as much about bundle size and network traffic, and yeah, so we didn't do any of that.
Yeah, very interesting. I also liked when you mentioned to display like granular or detailed UI feedback during some loading, right? So I also think this is very important nowadays, not just to have like a general loading indicator there blocking the whole UI, but yeah, also like being transparent about at which kind of step some data gathering is just happening right now, and informing the user like about this. I think it's called like mostly perceived performance, right? So the users more likely accept some delays if they at least see the UI reacting pretty fast, even if still some data needs to be fetched. Yeah, that's very important in this context, especially, I would say, right?
Yeah, and that's also what I meant by saying it's not about the like performance itself of some UI like that, but it's more about what's possible to deliver a good user experience, and not about like looking at millisecond scores which might react a bit faster. In the end, that doesn't really matter if you can provide ways to to make it still look nice and good to use for the user. So
Yeah. Yeah. Okay. Cool. Let's take a look. The chat is a bit quiet today, so yeah, but yeah, I think then we can close this session for today. Thanks again. It was really super interesting. And I also, as a front-end engineer, I like to see more of some insights, especially how to like work with web technologies on hardware, right? This because the web is there as well. We can do awesome stuff nowadays. The framework ecosystem is really evolving, and many things got easier. Of course, with some other new challenges in parallel as well, as always. But otherwise, it would be boring, right? So, cool. Yeah, thanks again, and see you
Happy to
maybe
be here.
for another session. Yeah, thanks, and